Hello and welcome back to another episode of the Building HVAC Science Podcast. Our podcast aims to help create better, more knowledgeable HVAC and building performance pros by introducing them to each other and to topics of scientific and sometimes business and human interest. Our ultimate goal is to help our listeners create better environments for all people. Today's episode, Eric and I sit down with Dave Massner from SensorCon. Dave's been long involved in the world of portable gas detection, and he digs into some realities behind carbon monoxide, hydrogen sulfide, and oxygen sensing in both HVAC and industrial environments. In our conversation, we explore a lot of little niches, a lot of little roads. We talk about the lesser understood threats of hydrogen sulfide gas, that's H₂S, and how it can travel with the wind and oil and gas regions and incapacitate workers before they really realize what's happening. We talk about some physiology and some chemistry and the grim speed at which exposure can become deadly. One of the quotes from the episode is, hydrogen sulfide doesn't announce itself. It can drift in, hit your mucus membranes, and start causing real harm before you know it's there. Toward the end, we highlight SensorCon's ongoing efforts in training, education, transparency, and I'll have some links in the show notes to explain where their blog posts, their videos, some of their resources are, and of course, links to where you can get their products at True Tech Tools. Okay, let's get into the episode where Eric and I talk with Dave Massner from SensorCon about the hidden hazards of CO, H₂S, and the tech behind modern gas detection.
Hey everyone, welcome back to the Building HVAC Science Podcast. Bill Spohn way over there, Eric Kaiser right over here, and special guest today, I'm not sure where he's at, but he's somewhere over there. Mr. Dave Massner from SensorCon. Hey, Dave.
How's it going, guys?
If you see the video file, it may look like he's on a SpaceX rocket.
Kind of looks like he's got some spaceship vibes going on there.
I'm down in Corpus Christi, Texas, Eric.
Got it.
Oh, nice. So it's a little bit warmer than where Bill and I are at right now, probably.
It is slightly warmer, although today it's only 59 degrees and windy, so it's Texas cold.
Yeah, because I think it got up into the low 30s here today, maybe.
Yeah, we got away from that.
But it's sunny.
So Eric and I had, I think, the first chance to meet Dave in person, but we had corresponded with him before up to this point, and Dave is our contact at SensorCon. And I'll let Dave explain what SensorCon is, his background, and we'll get into a bunch of things about instruments, measurements.
SensorCon itself was started clear back, I don't know, something like 2011, 2012, with the current boss right now is Ben Madoff, but we are under the Molex umbrella. So Molex owns us and Koch Industries owns Molex. And so we're all part of one big family. But when they bought them, they were just making their one and only wearable Inspector series carbon monoxide detector and hydrogen sulfide detector. And then they've expanded the SensorCon business to work with all kinds of their air compliance side of things, which I had joined the company in 2016 to work on that side of things as a sensor design engineer. So I was designing sensor systems for oil and gas refinery, stuff like that, with the idea being like you take a few of these sensors and blanket a refinery, and we can tell you within like a 5x5 window of certainty where a leak is happening in your facility. That was where my efforts were being spent up until about October of last year, 2024. And then I moved into this role as a sales engineer, which this is honestly my first foray into anything sales related my entire life. I've been an engineer. I graduated from Purdue University with 2 degrees in engineering, and I've been doing that my whole life. And so now this is the side that I always tried to avoid, but now I'm here doing the number game. But honestly, it's a fun place to be because I get to speak about all the technical details, all the stuff. I get to bring that expertise into this, to me, the arena that has always been lacking that expertise. You got to have sales, but the sales guys are typically not the ones really well trained in all of the devices and like how these things work. So it is nice to be able to bring that background into it. So they grew the SensorCon business quite a bit after they bought us. And that's where we've been ever since, is just continuing to increase that market. We introduced a new product earlier this year called the Protector, which that's more of an industrial focused carbon monoxide monitor. And we're looking to expand that into other gases as well, like hydrogen sulfide, oxygen, other big ones like that on the market. And that has a whole bunch of different features and stuff that we can talk about that in a little bit. But my background specifically, before I joined Molex, I grew up in Northwest Indiana outside of Chicago. I went to Purdue University for electrical and mechanical engineering. My previous company was actually one of our competitors, Sensit Technologies, and they put me through college. They, on a verbal agreement that I would give them 5 years after I graduate. I gave them 7. And then Molex came along. I wasn't even looking for a job. They found me on LinkedIn and said, "Hey, you have the exact skill set we're looking for. You want to come design new stuff for a 40% pay raise?" And I said, "Yes, I do." And so I've been here ever since. And it's been a fun ride. I've been able to design all kinds of new stuff. And now I'm enjoying just bringing industry expertise to the table and see. I always describe myself as an industrial psychologist. I always wanted to show up to a facility and be like, "Hey, tell me what all your problems are. We'll come up with solutions." So that's where we're at with the company now.
You'd mentioned carbon monoxide, H₂S, oxygen type sensors and detectors and monitors. And I'm guessing most of our listeners are familiar with carbon monoxide poisoning, its effect on people's physiology, where the sources are in heating systems and things like that, and combustion systems. But the H₂S and O2 might need a little bit of unfolding of where those parameters lie. And I'm going to interject a little thing that I learned just this week. There's a TV show called Landman on Paramount, and it's produced by Taylor Sheridan, who did the Yellowstone series. And they had an incident where they were walking out of their trucks in this scene, and they clipped on these yellow monitors onto their collars. And I'm like, this is going to be something about gas detection. I know it.
Yep.
And it was something I never realized, but hydrogen sulfide can rise in oil fields and gas fields and then be blown across with the wind. And like, you don't know it's coming, and it can kill you or severely injure you. Can you expound on that a little?
So H₂S, hydrogen sulfide, colloquially known as sewer gas. So when you smell that rotten egg smell coming at you, that's what that hydrogen sulfide is. And it is extremely deadly. It is one of the things that needs to be, I talked about it, every refinery, every oil processing facility, every wastewater treatment plant. They have to be very well versed in these types of things, because it is a dirty cheat the way that thing can kill you, because we can smell hydrogen sulfide gas in the parts per trillion. Our nose is very sensitive to it. When we talk about test gas for something like this, it's typically like 25 parts per million is a test gas. That's a level that you can smell it. You don't want to sit there inhaling it all day, but that's a somewhat safe level to be exposed to for a very short amount of time if you're going to be sitting there testing a device. But when you start getting into 100 ppm, 200 ppm, even just a quick deep breath of that could have long-lasting effects and consequences on your health. When you start getting up to 500 ppm, one single breath can kill you. That is steeped in it. And the problem is, once you get past 25, 35 ppm, your nose starts to go nose blind. You start to lose the ability to ever smell it anymore. So you might think you're now safe in a safe environment, but you're not. It's just even higher than what you thought. And with every breath, it's killing you. It's a terrifying concept, but I had an exposure myself at a facility, and it's one of those heavier than air gases. And the problem was, I was standing at the top of a vessel right next to a large coker unit. And I knew that they had just started cutting the drums, but if everything is sealed the way it's supposed to be, none of that's supposed to be coming outside of there. And all of a sudden I smelled it just slightly. I'm like, all right, well, that's normal. It could just be a little bit leaking out. But the sensor system I'm working on was that one that I was telling you about that we put in refineries. And I was sitting there, happened to be looking at the live output of that sensor. And I'm wearing a hydrogen sulfide sensor, like one of those little yellow ones that you just talked about, a little BW clip. And all of a sudden, the problem is those electrochemical sensors, they lag quite a bit. All the ones across the industry, they got anywhere from 10 to 15 seconds. Their T90 time is listed, and it's pretty slow. And the sensor I was looking at was a photoionization detector. So it had an instantaneous response. And all of a sudden I saw it spike, and I'm like, oh. And so I couldn't even take a deep breath. I just had to stop with the breath I have and try to get down the ladder as fast as I possibly could. I had 40 feet to go, and I'm just hoofing it as fast as I can on like hardly any breath. And halfway down the ladder, my monitor on my shoulder starts going off. And I'm like, oh, that's really not good, because now it knows what's up. And I get down to the bottom, and I ran probably 20, 30 feet away before I finally just had to take a deep breath in. And thankfully, like, there wasn't a whole lot of H₂S around me. But had I stayed up there, I would have been exposed to 100 ppm plus, because the fact that that monitor was going off into alarm halfway down, that was a really bad indicator. I was thankful that I got out. I know plenty of people in the industry that didn't get out. So that's why those are incredibly important. And I've always told people that thing will save your life. However, like in a really bad instance, it might not, because you have that 10 to 15 seconds that you have to wait. You could be the one caught in it, but it's going to save everybody else's life that hears that thing going off. When they see you down, they know not to go to try to save you. As sad as that sounds, like that's a very important thing for people to know.
My understanding, correct me if you know differently, but the H₂S gas gets into your mucus linings, into your lungs, anywhere it contacts water-based substances in your body, turns it to hydrochloric acid, and it starts to burn from the inside out. Is that correct?
You got it. And it's incredibly dangerous for that reason. Like once it starts doing damage, that damage is very hard to reverse.
What levels of H₂S are, we'll say, safe? And I'm doing these air quotes here, safe and not safe. And where all else, other than we're talking about industrial plants, obviously industrial settings like oil fields and things like that, where else can H₂S be found and or come from?
Oil is like one of the primary ones. Like when you talk about oil, pulp and paper mills, anywhere where you have like a whole lot of wastewater treatment in general, you're going to be pulling a lot of sulfide compounds. It builds up in sewers as well as a byproduct of waste. So that's why you commonly see it at the wastewater treatment plants and stuff like that. But typically it's really big industrial facilities and wastewater treatment plants where you're going to find it the most. If it's one of those things where you suddenly smell a whole lot of rotten eggs coming out of your local sewer, that's where you need to contact your local government, your local municipality, and say, hey, there seems to be a buildup of sewer gas, because not only is it dangerous from a toxicity standpoint, but it is explosive in high amounts. And the fact that it's usually associated with the release of like methane, some type of other natural gas that is also explosive, that's a deadly combination. You don't want that kind of thing building up under your street, obviously. And when I was at Sensit for 12 years, that's what I was designing, was their whole line catalog of handheld and wearable detectors. And we focused a lot on finding different types of gases under the ground. Municipalities do what's called bar hole surveys. They'll go out and punch holes in the ground above where their pipes are and take readings, pulling air through those little bars that they stick in the ground to make sure that they're not leaching out natural gas or any other thing that they're carrying in their pipelines out into the neighborhood, out into the city.
So that's H₂S. The other one you mentioned was oxygen. Tell us about why you'd want to measure oxygen and what are you measuring for and where can problems occur?
So oxygen, it's becoming increasingly rare to see oxygen offered as like a single gas option because it's so important to use it in conjunction with other gases. But its primary application is for confined spaces. I want to go down into this little pit, or I need to get down into this area, like under a really big distillation column or something, the support structure for whatever reason, because we got a leak coming down. We need to see where it's coming. I don't want you going into that confined space with only one way out without measuring the air in there, without knowing if you need some apparatus, because it could be the oxygen is depleted. It could be that there is a gas source in there that is going to be an asphyxiant because it pushed all the oxygen out. It could be that you're going into a toxic atmosphere. But the number one indicator that we need first is to know, is there enough oxygen in there for you? Because if there's not, we don't want you going in there. On the flip side, I want to know if that's an oxygen-rich atmosphere. Is oxygen being fed into it? Is it greater than 23%? Because now I know you're at a greater risk for an explosion.
So what's too low? At what point? And like these are all we're talking health effects.
Typically below 19.5%. But once it starts getting below 19, that's when you're going to start. It's not necessarily an acute health risk. It's a secondary health risk because you're going to start making bad decisions. We want to keep you from making bad decisions, especially when you're already in a bad environment.
Interesting.
So you really want to stay between that 19.5 and 23%. That's your sweet spot for oxygen.
And that's where most of your oxygen alarms on the market, they're going to be set. Like, oh, this went below 19.5, go into alarm. This went above 23%, go into alarm.
So what's the most interesting project you've worked on, if you could talk about?
The most interesting one was actually not, I would say there's two of them. And one of them is actually back at Sensit, was a competitor of ours now, obviously, but not in the space that we're currently working in because we don't do LEL, like explosion detection, explosive gas detection here at SensorCon. So I would gladly speak about it. It was called the Portable Methane Detector, or PMD. And we actually partnered with a triple doctorate from Carnegie Mellon University. It was one of the smartest guys I've ever met. And you know it too, because the guy was so humble and he had the ability to take some of the craziest theoretical physics and just ideas and concepts and distill them into that explain it like I'm five kind of explanation that you could just sit there and listen to all day. Like, would you please tell me more about how the world works? Because you did a really good job of making me understand something very complex. And this guy helped us design what to get single part per billion, like ppb level accuracy and resolution on methane gas would normally take like a laser, something that you're going to pay like $3,500 just for the diode itself, let alone all the parts you're building around it. And he was like, no, I can come up with this idea where I take light from a natural tungsten bulb and I put it through a lithium niobate crystal and I put it at a certain excitation and frequency. And I double wrap this with a couple heaters to hold an exact temperature. And then I put that into an indium arsenide detector. And then I can read the exact amount of absorption that's going on with this particular gas. And it only will see methane and nothing else. How do you come up with something like that? I have no idea, but I got to work on that project. I got to help him design and I got to do the electrical and mechanical layouts of this whole thing. That was cool. That was one of the funnest things I ever got to build because I got to work on the forefront of a technology that I can't even imagine how you even approach coming up with a concept like that. And yeah, this guy's like, oh yeah, it's just second nature. You just do this and this. I'm like, oh, okay. Yeah, totally. Second nature. But I think the second best one I ever was that project that I was telling you about, like before I took this role, that I got to help design that. I got to work hand in hand with the EPA and Coke through a creative research agreement and say like, all right, how can we reduce emissions in refineries, especially the ones that, because the way that they had been doing things, I don't know if you're familiar with, they have a program at refineries called leak detection and repair. And essentially you pay groups of tens to hundreds of guys, depending on the size of your facility, to go around every day, all the time, with a little probe around every single valve, connection, screwed connection, component, whatever, every single interface where there could be a leak, and write it down and monitor. What did you see? Did you see nothing? Every single one of those is tagged. There are thousands of them. Like, to give you an idea, and not all components are in the system, just ones that they consider critical. At the local facility here, where I was working out of, we had 750,000 components on the annual register. And so these guys are going around.
It's like painting the Golden Gate Bridge. You'll never finish.
Right.
Before you start again.
Just by hearing this, you can tell this is already going to be a very monotonous job. But on top of the monotony, it's dangerous. And on top of the danger, and when you're down in Texas and it's July and August, it's 115 degree heat index plus the top. You're standing on top of a reactor. It's 135 degrees up there. You're in full gear carrying 30 pounds of all your equipment. And then on the flip side of that, you go up to Minnesota, you got a refinery up there and you're doing that in negative 20 degrees. And you don't get to stop. It has to happen all the time. And so, yes, you can imagine somebody's doing a 36-inch valve and they're going all the way around this thing as slow as possible so they don't miss anything.
And reaction time of the sensor and all that.
They might have actually done a good job at 8 a.m. when they started their shift. Do you think they're taking the time to do that exactly on every single component by the time the day is over? Not a chance. And so, like, the human element of this is insane. They had people that would falsify things. Once they started geotagging, they were like, hey, how come this guy did 300 readings sitting at a Sonic parking lot? He didn't. He was just making up numbers in his truck.
Have you eaten Sonic lately?
I do love their chili cheese dogs.
Yes. They do make a good corn dog, too.
They do. Their corn dogs are delicious. And the human element is huge. When we could come up with a system that said, like, all right, instead of doing that, how about spending all day, every day looking for a needle in a haystack? How about we just tell you where the needle is and you use that? And so that the whole thing turned the system and the idea behind it on its head. That was a very fun thing to work on because that gets to improve humanity. That gets to improve lives and save the air that's around these refineries and stuff like that.
One thing Eric and I were talking about, I think we were at the Heat Pump Summit. We were talking about signal to noise and raw sensor output.
Oh, yeah.
And I remember some of this from my days at Backrack, especially in product development. But I'm thinking that you might be a good person to kind of crack that topic open.
Sure. So like signal to noise, especially like at a component level, like from the sensors coming in, that's kind of an industry secret for every single one of the companies is how do we tackle this? How do we filter all these sensors? But also, I will say this, over the last 20 years, the sensors themselves have gotten so much better and so much smarter at being able to do this that the outputs now are so good and predictable. And if they're not linear, at least they're predictable. Because one of the worst things about a lot of components and sensors back in the day was if they weren't linear, they were typically like either logarithmic or exponential. And if you had a baseline shift of even a marginal like 2 to 3%, it didn't matter, because if they were exponential or logarithmic, the readings are crazy off the scale with even just a little shift like that. And so now with the advent of these much smarter embedded processors, for instance, like our protector device, the one that we just launched, it used to be the average industry, like the industry average lifespan of a wearable is 2 years. And that wasn't because necessarily of the sensor. The average sensor life is 2 years, but the batteries couldn't last that long. Especially, they're supposed to be designed for, all right, we need this thing to last for an average of 2 minutes of alarm per day. At the worst case scenario, minus 20 degrees is what they're rated for the average one in the industry. With all the processing power for portable devices for years, they made slow improvements. They made eked out changes. You saw it go from your old cell phone back in the day, went from you needed to recharge it daily to then you needed to recharge it once every 2 weeks. But then we got smartphones. And they took way more power. So you were still recharging them daily. But now you're getting to the point where even a smartphone with heavy usage, you probably don't even have to recharge it at the end of the day. You're just doing it because you're like, wow, it's at 45%.
Force a habit.
Force a habit. I need it for tomorrow. But the batteries get so much better. So we're able to do so much more with these. And so now you're starting to see all these little sensors pop out all over the market with GPS, with cellular built into them, stuff like that. They don't last on a primary cell, obviously, but they can recharge them really easily. And they're using those overnight. So you get companies like our competitors like Blackline. To me, they're the ones that are making, it's like an engineer that was never told no. Oh yeah, you can put all this stuff in there. And they make cool stuff, but it's expensive. You're going to get what you pay for. But they do make cool stuff. And where we looked at that and we were like, well, hey, if everybody and their brother is rocking $1,000 supercomputer in their pocket and it has Bluetooth in it, why would I build all those smarts into the device and make it cost a ton when I can literally just talk to that device and I can give you all of that information? I can tell you where your location is. I can do time stamping and all of that stuff. And I can just send you information if you have issues. So I could tell your supervisor that 3 of your guys, hey, they just got exposed to carbon monoxide out in the field. Do you want to know about that? Well, it may be even from a legal standpoint, from a CYA standpoint, because today, if one of your HVAC guys goes into a house, they fix everything, whatever, and then they leave. And a week later, this house ends up with a carbon monoxide issue. They have a poisoning event. They're going to go back and be like, well, we just had this HVAC company out here and they fixed our furnace. Were they negligent? Who's to say? But if your guys went out there and they had date and timestamp readings that said, oh no, we actually did. And we checked it even with our analyzer after that. But now I have 2 sources saying, no, there was absolutely no carbon monoxide in this house when we left. Cool. You just got absolved legally. Something else happened after you left, but at least you were able to say we weren't involved in that. And I think that's a huge peace of mind.
That's big. It's where we're looking at more and more accurate and reliable data with all these communication devices. I do want to pull us back just a little bit to the whole signal to noise and sensors. And
oh yeah, sorry.
No. I mean, you went down a great road there, and it's one that I think Bill and I are very passionate about is good quality data coming out from the technicians. And we're probably going to go down that road here in a little bit. But I want to talk about these sensors a little bit more. And you said something there that the electronics can really make a big difference. And the programming of those electronics, how much can those electronics really change the accuracy of the output?
Definitely.
Much, and how all that's controlled? Because signal to noise, from what I understand it, and you're probably going to correct me here, is basically you get noise on an electronic signal coming out of a sensor. So you might get a nice clean, and then suddenly you're going to get a huge high blip or a really low blip. And you got to understand from a programming standpoint how to program that out of it. Is that kind of an accurate assessment?
That's actually a really good explanation. And there's multiple ways to approach this. And sometimes you have to use multiple ways against it as well. There's 2 types of noise that we need to address. One is static noise, like one that is a constant that we need to filter out. And then there's intermittent noise issues. I'll give you for instance. Back in the day, we had some H₂S sensors that were from an off the shelf. They were from a reputable sensor company. But I had a whole bunch of contractors at a job site out in Canton, Ohio, that were calling us up and saying, hey, these H₂S sensors are suddenly spiking to 1,000 ppm and then just disappearing like that. And I'm like, well, that doesn't sound right. An H₂S sensor can't respond that quickly, and it can't lose its reading that quickly. So something's very obviously up. And we had done all of the testing across the board that you're supposed to do on sensors. We even sent them off to a lab to do the frequency testing and stuff like that. But they were never tested like in situation in a circuit while running to see if they're mostly tested against frequency hardening, to see if a frequency is not going to destroy the electronics inside of your device. Well, it turns out these guys were using some proprietary 833 megahertz Motorola radios. And every single time they would key up the radio, that antenna or that element inside that sensor was a perfect wavelength of a harmonic that it just acted like an antenna, and it just, boom, it hammered the reading through the roof. And we're like, well, how in the world are you going to design a sensor? Like, it needed to be that size. And it's not like they were going to recall the entire design because of one radio type. So we looked at it and we're like, well, knowing the characteristics of a sensor, we know that you're never going to see a spike through the roof that's going to change this rapidly on this type of sensor, nor is it ever going to come down that quickly. So we just trained the software to ignore it. Said, well, if you get a big spike like that, that's clearly not an actual reading. So just ignore it. And if the sensor is actually responding to stuff, that baseline is going to be shifting up and down through that noise, regardless of whether that's taking place. That's how you slowly characterize and deal with intermittent issues. Static ones, you should be able to see right away. When I plug that sensor in and I'm testing it with interference and everything else around me, I can see, all right, the circuit itself, whether maybe I'm using a noisy power supply, like a switching power supply, and I don't have it really dialed in. You can hear a bad one when you plug it into the wall. It gives you that squeal. Like, and the older you get, the less you hear it because you stop hearing that high frequency. Both a blessing and a curse.
Or if you're like my ears, they just have it constantly now, right?
Yeah, tinnitus, right? Make it go away. And that kind of noise affects your circuit as well. So you will start to see those waves and those spikes. That noise shows up badly. If you take a scope and look at the output of that sensor, you're going to see it. Well, that's when you build a low pass, a high pass, whatever, a frequency pass filter into your circuitry to say, I don't care about anything outside of this range. If it's changing this rapidly, if it's above this frequency, below this frequency, I don't want to see it. I just want to see a steady, solid change in the output, what I expect to see from this type of sensor. And so you build your electronics around that accordingly. And the great thing is, like I said, with these new processors that take much lower power and they operate so much faster, now we can do so much more processing these days in a handheld device or a wearable device that'll last me 5 years on a single battery. And I can do way more advanced algorithms and processing in it. So I can look for these types of things. I don't necessarily have to even build circuitry around them anymore. I can just use the software to ignore them and see through them. On the flip side of that, now I can use the software to make better predictions, to give me better information than I was ever able to before. Now with that protector device, it has a 5-year battery life, which we've never seen that in a wearable in the industry before. But now we have the processing capability to do that. But now I can get you, we've talked about how these are slow. They're slow sensors. They take 10, 15, 20 seconds to get up to alarm to that T90, which means time to 90% of the reading that I'm giving it.
Final reading, yeah.
If I'm giving it 100 ppm, I want to know that time to 90 ppm. And since the average is 15 to 20 seconds, well, we don't need that anymore. These are very linear sensors. Now I can tell you in 3 to 5 seconds with good processing power, nope, you're on your way up to a big reading. I'm just going to put you an alarm now. So that's what we patented that feature. We're doing that on the protector because why do I want you standing in the middle of a potential cloud of toxic gas? If I could tell you way ahead of time, I know you're headed there, which I think that's a great development. That takes advantage of those improvements in signal to noise ratio and the improved capability, because 10 years ago, we wouldn't have a clean enough signal or the processing power to analyze that clean enough signal that quickly.
Yeah, using the acceleration, it can't decelerate that fast. So it's accelerating towards a higher value. Very, very clever.
Yeah, and especially if you know what the sensor response time is and you look at that acceleration rate and the rise rate, you can probably predict that slope almost exactly, right?
Yes, that's the great thing about it is one of our guys basically looked at that and they were like, well, why isn't anybody else doing this? And honestly, it's because A lot of the companies on the market, like I'll be honest, as an engineer, I love our competitors. I love seeing what they come up with. I love visiting them at trade shows and I tell them about all the new stuff that we just came up with. And they tell me about all the new stuff that they came up with. And that's awesome. That helps everybody. That helps the consumer the most because every time I see something cool that they did, I'm like, all right, I want to do that, but better. I want to figure out a better way to do it. And it just, we all build off of each other and come up with neat ideas to keep everybody even safer.
Yeah, it's great when people can build off of each other like that. A good idea often develops another good idea.
It does, for sure.
You doing some trainings around or webinars, or how do you communicate all this great stuff besides wonderful podcasts like this one?
I really should. I honestly wish I had a bigger audience to be able to do this stuff and actually do some visual trainings and webinars and stuff like that. I think it would be a good idea to start it up because I think for the average consumer, lack of awareness is the biggest problem. I can give them sensors all day long, but if they don't know how to interpret these things, if they don't know how to use them and understand the readings, or even understand like what's a good product and a bad product. If I hop on Amazon today, I can see, and I search for portable CO sensor, I'm going to get a ton of them. And the vast majority of them are going to be way cheaper than the product I am offering because they're kind of an Alibaba fly-by-night company. You'll notice that one design has like 8 company names. And that's because the moment they get shut down, it's fine. They go to the next one and whatever else. And they're probably utilizing the same exact technology that I am. They're probably utilizing the same sensor type, but I have no idea what manufacturer they're using. I don't know like the quality or the QC process, and I don't know what kind of records they keep for those kind of things. And if I'm going to be buying a device that I'm going to be staking my life on, then I'm going to be like, oh yeah, this thing's going to tell me if I'm going to die or not. I don't want it to be from a company that's going to dry up and disappear tomorrow. I want it to be from one that I can trust, that I know that they actually care and understand their sensor making process, and that I can get somebody on the phone tomorrow if I need them. And they're going to tell me like, oh yeah, this is what's wrong or isn't wrong. And if it's broken, yes, we'll replace it. Absolutely. As opposed to, oh, just buy a new one. And I've had people say to me before, well, I can buy 3 of these for the price that I get for one of yours. Okay, well, buy 2 of them at least then, so that if one is malfunctioning, you know that the other one is okay. But I look in the comments and I see people like, oh, this thing failed after 3 months or 6 months. Yeah, it probably did. And it's terrifying to me that a lot of these will fail in such a way that they won't respond or they're off and you don't even know it. That is so much worse than a false positive. I'll take a false positive any day telling me that there is gas when there isn't, rather than its evil twin, which says, nope, I don't see a single thing. Sensor's not responding to anything. And there is actually a ton of gas in the room. That is terrifying to me. People can save money. They can buy the cheaper ones. But when it comes to something that you're staking your life on, why would you do that? I don't understand that.
Well, it sounds to me like a lot of that is, even if maybe you're using the same type of sensor or maybe the exact same sensor, the electronics behind that sensor are going to be a big thing, because if somebody doesn't figure out how to filter out that noise well, or they don't figure out, hey, we got to have XYZ circuitry in here to say this sensor just failed and isn't working anymore.
Yep.
Like you said, trust in your life.
That's a great point, Eric, because that's exactly what you get. In a premium device, it will tell you, hey, there's an error. There's something wrong internally. Like it does a constant check to say like, nope, this isn't working correctly. And a cheap device, you're more than likely not going to get any indication like that, because what's their incentive? They're not building it into that. They're not building it to any standards. It's not being certified to any standard, especially if they're selling it as a portable. It doesn't have to meet like the UL standards and stuff like that the home devices have to. So when I see stuff like that online, I find them terrifying because they have a crazy amount of views. They have a ton of people buying them in the tens of thousands. And they're all sitting there thinking like, yeah, I'm perfectly protected. And they're not. And that kind of goes to also, even in the HVAC industry, I've talked to people that may be down south in Florida or Texas markets, and they're like, well, we don't have a lot of sources of carbon monoxide. It doesn't make sense for me to buy one of those. And I'm like, oh, that is so far from true. And I wish you didn't think that way. But that's where we come back to awareness, because just because we made a lot of heat pumps down here, that doesn't mean that there's no sources. Like some people might have gas stoves. Some people might have gas water heaters, even if the rest of their stuff is electric. But okay, fine. Maybe your entire area doesn't allow natural gas anything. That's fine. They still have cars parking in their garages. And if your neighbor, like if you're in adjoined housing and you got a neighbor that's hard of hearing and has a push button start, and I don't know about you, but I've definitely walked out of my car before without realizing I didn't turn it off. And if I was hard of hearing, that's 1,000 times even harder. This is a real situation that happened. A guy, 80-year-old guy, was living in a duplex, got in his house, didn't turn off his car because it's push button, didn't even think about it, fob in his pocket, goes into his house. An hour and a half later, both him and his neighbors are carbon monoxide poisoned because he didn't even realize he had the thing running. And people, you don't think about the way that the permeability of how long do you think it takes carbon monoxide? You guys might actually know this. How long do you think it takes carbon monoxide to absorb through a brick wall into another house if they're adjoined?
That's a good question. Now, we're just talking about a brick wall. We're not talking about like a brick and frame wall or anything like that.
Well, no, let's say brick and frame built to modern standards. So it has the firewall, it has the insulation, it has all of the proper code, it has the drywall, whatever. Let's say that. How long do you think? Because, okay, so I'm going to preface this by saying they did a study at one of the NCOAA affiliates in a college, Leeds College, I believe it was, in the UK. And they built a row of modern row houses, like 3 in a row, townhouses, all to the newest standards. And they put a carbon monoxide leak in one of them and monitored to see how long it would take to get into housing unit 2 and 3. Now, I don't remember what the leak rate was per hour, but it was like a standard, what you could expect if your flame went out, right, on like your hot water heater, something like that, or there was improper combustion. How long do you think it took to get through to the 3rd unit?
Boy, I have no idea. I'm going to say hours, maybe.
And you're right. But most people, I think, would guess days to weeks. And it wasn't. It was literally hours to get all the way over into that 3rd unit to the point where it is hazardous to health.
Wow.
So that's why it's absolutely critical. And there's other ones, right? Backup generators and all kinds of other sources that people don't think about on a regular basis. But any of these guys, they have the opportunity. They're going into so many more houses than first responders, because first responders, they're going into houses when they have to, which is hopefully rare. HVAC guys, they're going into houses hopefully once a year for people to do regular maintenance, but at least every couple years. They have the opportunity to save so many lives because they could go walking into a house, your home plug-in carbon monoxide detector, which you guys probably know this one. It's not meant to go off in anything lower than 30 ppm. It will not. It is built to a UL standard to say do not alarm for less than 30 ppm for a minimum of 30 days. After 30 days, you as a manufacturer can do what you want. You can tell the customer that, yeah, it's alarming, but most of them are never going to. So you could be sitting there in 20 to 29 ppm every day of your entire life and just think, you know what? I get headaches. I get nauseous a lot. I forget things. No, you're just living in low level carbon monoxide and you're slowly poisoning yourself to death. You're giving yourself a significantly higher chance of Alzheimer's, dementia, all kinds of terrible things because you're just living in that. And you have a monitor that's not going to tell you.
That's why we make a point of offering low level CO alarms that don't align with that standard. And we've been doing that for more than a decade.
Which is phenomenal.
It's found 2 great brands and promote them all the time. In fact, every TruTech employee gets a new one every 5 years.
That's awesome.
So, Bill, let me ask you a question. You got an all-electric house, right?
Yes, sir.
Do you have a low-level CO monitor in your house?
Yes, I do.
So do I. And again, all-electric house, I've got one in my bedroom. Why? Just like Dave said, I've got an attached garage. I've got outdoor combustion appliances like grills, generators, lawnmowers.
Long equipment. Yeah.
I had one where I was running the lawnmower outside my house. Well, guess what? The fresh air intake is, let me correct that real quick.
Outdoor air.
Outdoor air intake, not fresh air, because sometimes outdoor air is not fresher than indoor air. And this is a thing that we get into in the industry. We often talk about fresh air intakes, right?
That's a good distinction.
That outdoor air intake is bringing in stuff from my weed eater, from my lawnmower, whatever is happening to be running, maybe the road next to my house if it's got a lot of traffic on it and the wind's blowing in the right direction. You can bring it into the house. And that's a real thing. The first time I've ever had my alarm go off in the house, we were running an insulation vacuum, pulling insulation out of the attic to be able to re-insulate. And it was 30 feet from the house. Now the garage door was open. The door between the garage and the house was open. And that CO monitor is on the far end of the house. But the wind was blowing in the right direction that it pressurized and blew all of that exhaust from the gas generator that's 30 feet away from the garage into the garage and all the way through the other end of the house. And I heard it going off and I'm like, what is that? And it took me a couple minutes to walk and figure out what it was. And I'm like, then I saw it and I'm like, oh, yep, there we go.
Yeah. The nice thing is, like, at least you recognize that, like, you've been trained, you understand where these things can come from. But the average user, they're not even questioning that. And what I find even scarier is that even when the people that are trying to do good, they're trying to do right, they buy a monitor. When it goes off, their very first reaction, it's like a car alarm. We get alarm fatigue immensely in this country. When's the last time you heard a car alarm go off and you thought, somebody's stealing a car? You don't. You're like, turn that damn thing off.
Shut that off.
And that's exactly where we're at with a lot of these monitors. I get customers that call me up and they're like, hey, my alarm's going off. Something's wrong with it. I'm like, well, why is that your first thought? That something's going wrong with it? Shouldn't your first thought be, oh, I should get out of here. Something's wrong. I had a guy call me up. He's like, hey, this thing keeps going off every time I walk over into the shop. And I'm like, does it clear out right away when you go walking outside? Oh, I didn't even think about that. Hang on, let me go check. He walks outside, clears out right away. I'm like, does it go back up right when you go walking back into the shop? Boy, yeah, it does. I was like, well, you definitely have carbon monoxide. Then he goes, on second thought, we did have a guy here servicing our furnace that's right here in the middle of the shop floor yesterday. And so he calls him up and the guy comes back out and says he realized they had two burners. They were not properly combusting. It was just throwing off carbon monoxide in the middle of their shop. He's like, I'm really glad I made that phone call today.
Yeah.
We see this sometimes when people get new pieces of equipment. And it happens a lot when somebody goes from maybe one piece of equipment to another piece of equipment or instrument, one instrument to another instrument. And if that new instrument doesn't read exactly the same as their old instrument, automatically the new instrument is bad. Now, me, as an instrument person, I'm going to say the new instrument is probably more likely to be a higher accuracy because it's new and it's more recently been built, where that old one may have been beat up on, had some wear and tear on it. But our brains think of it backwards because we're used to that old one and we automatically think that's the best thing we've got. And that's our comparator.
Yeah. What they call that recency bias, something like that.
Yeah.
Yeah.
As we wrap up here today, what are some of the most important things our listeners should be paying attention to when it comes to sensors, sensor technology?
I think it's just important that you buy your sensors from a reputable brand, from somebody that you can trust. It doesn't have to be ours. And like I've always told customers that I don't care that you buy ours. I care that you buy somebody's, and that it's something that you trust and that it's what you can afford. But hopefully, my grandpa always told me never go cheap on things that go between you and the ground, and that's shoes, tires, and mattresses. And I agree, because you spend an enormous amount of your life on those things. But also, I feel like that applies to anything that is a life-saving device. Is if I look at this and I do see that it's cheap, all right, but I need to wonder why. Go read the reviews, especially read the bad ones, and make sure that they're reputable. But I think it's important to understand that everybody is at risk of carbon monoxide exposure, regardless of where you live, especially if you're one that likes to travel. That there's only one state in the union currently right now that mandates carbon monoxide detectors in every single room, and that is Minnesota. We're trying to change that, but it's slow to change. And over 100 people die every year of carbon monoxide poisoning from hotels. So it's important to have something with you that you can travel with you that takes you in your car. Your car is, if something goes bad, you get a disconnect in your exhaust. You could be carbon monoxide poisoned without realizing it. There's all kinds of things. So yeah, I think it's just important to realize everywhere you go, you are at risk. It's not one of those things that should be overlooked. I wish there was better training and stuff like that available out there. And just the importance of having a HVAC company that you actually trust. And I think the average user doesn't, and I think this applies to HVAC companies too, doesn't know and understand that little accreditation symbol, like say you're NATE accredited or whatever. I, as the consumer, I don't know or care what that means until you tell me what that means. Tell me why that accreditation means something that I, as a consumer, should care about, that it means I should trust you more. I need to know that. If you're going to put these things up there and say, this is why you should trust me over X and Y and Z, I want to know why that is. Is it because that you are certified to not be negligent? Is it you're certified that you know these checklists and procedures to go through things that's going to make my home safer than the guy down the road? I need to know those things. As the average Joe Blow speaking to you guys, the HVAC guys, this is what I want to know. That's what I would say.
Excellent. Thank you for joining us, Dave. It's been a real pleasure. I look forward to being in touch. I found a couple of blog posts on your SensorCon website, which I'll include in the show notes.
Oh, please do.
Got some good details there about using and some of the videos, calibrating and use of the CO monitors your product. So thanks again for coming on, and I wish you happy holidays, and we'll get you back when we got some more to cover.
Sounds great, guys. This was awesome. Nice talking to you.
Thanks.
Thanks, Dave.
Take care.
Thanks for tuning in to this episode of the Building HVAC Science Podcast. Some of the topics we discussed require technical training for proper interpretation or safe execution. So if you're a trained pro, you can proceed immediately. If you're not, please consult with a pro or perhaps get some training. And hire a pro if you're not a pro. The Building HVAC Science Podcast is a production of TruTech Tools Limited. Full disclosure, I'm the owner of TruTech. And the opinions expressed are those of my guests, my co-hosts, or myself, depending who is speaking, of course. You can also follow Building HVAC Science on Facebook by typing Building HVAC Science into the search bar. I'm having trouble saying that today. If you have any questions or wish to suggest a topic, you can always reach out to us at marketing@trutechtools.com. That's TRUTECHTOOLS.com. And if you're in the market for any tools or test instruments mentioned in the podcast, look at what we carry at trutechtools.com. And you can use the offer code HVACBS for a nice discount. Thank you for listening to and following the Building HVAC Science Podcast. Until next time, take care.